When you turn this knob, the LEDs respond instantly. And that's the ESP32 converting analog to digital signals. I'm Colin, and I'll guide you step by step how to build, code, and our project today. Now all the parts you need to make it happen is a micro USB or ESP32 5 to 20 ohms resistors, a lot of jumper wires, a potentiometer, a power supply from an Arduino kit, a 5-volt battery, and 5 LEDs. Here's everything together, and don't forget to take a look at this before, so you can get an idea of what we're going to make. Okay, we're getting started. So we look at our ESP32, we already have that plugged into our board and our potentiometer. So what we did just there is we connected the 3.3 volts to the power rail on the side of the breadboard, and now we're connecting the sensor that takes the analog input and then transfers it into digital output. Note that analog is just a DC signal that goes from 0 to 3.3 volts or 5. It's just a changing voltage that goes one way. And then what we're doing here is we're plugging in the pins for a power source. So we have to provide it 5 volts in the bottom left pin. And now we're going to plug in ground. We're going to start at this pin so we can follow our schematic from before. Now that we have our ground pin and our power pin, we can start plugging in the next things here. So this top pin right here is going to be the ground we're going to provide to our potentiometer and then all of our LEDs. Note that it might be kind of hard to see what's going on here, so I best advise having the wiring diagram out so you can kind of figure out where I'm plugging things in at, because it might be hard to see. The setup was very makeshift, so I don't have a stand yet. Alright, now that we have all our LEDs in, we're going to be connecting the resistors to the short end legs of our LEDs. This allows us to have all of our all the ground connected to our LEDs. And then how we're going to turn them on is we're going to basically complete the circuit through the general output-input pins whenever we turn them on. This allows, you can wire this backwards, but it seems like it makes more sense if you go from power and then through the LED and then to ground. At least in my head it does. You can do the other way around. You can have the resistors to the power pin and then the board connects it to the ground. When you're completing that circuit, you need to power your devices. And there are some common mistakes you might come across. So when you're building these, like let's say you're very new, it's very easy to kind of like misplace your pins that you plug in. So like you need to make sure that they're all on the same rows. The breadboard's divided by rows, and if you're off by one, you're not going to be connecting to the right row of pins you want to plug in. So now we're going to take each of our outputs and then we're going to plug them into our LEDs here, so that when they do get powered, we are completing that circuit that it requires. As you can see here, it gets a little bit tough to plug it in. My camera is right underneath my hands. Now that we got that plugged in, we pretty much have everything. Now we just need to get our last LED. Let's see, how many LEDs? So we got 2 more LEDs left to plug in, and we're plugging these into the long leg side. That's the positive side of it. There's some terms like such as cathode, anode. Anode's the long leg, cathode's the short leg, I'm pretty sure. but you might hear that when people are talking about the positive and negative. And also make sure that your power from your power supply is set to the 5 volts, because if it's not, your microcontroller is not going to get enough voltage to actually start. That's something I ran into when I was first setting this up. And then also this last pin right here I'm plugging in, that basically checks the voltage on our setup. And you can see right here, everything works as intended. Before we get into coding, there are some important things to know, such as our equipment. We're using the ADC pin, and there's a lot of room for error, but just know that the ranges for the digital values is from 0 to 496, and the voltages for measuring from 0 to 3.3. And if you look at the graph, notice how it's not linear. This can cause a lot of problems if your project requires precision, as sometimes it raises a lot faster and sometimes it doesn't even know, for example, in 0 to that 1 decimal. And then there's electrical noise, so other devices can induce currents in our devices. So whenever you're planning these projects, make sure there's no like devices that has like a high inductance that can induce a current into our circuit. And let's get into the coding. Alright, this is the Arduino IDE. If you need any help setting this up, let me know in the comments and I can give you some advice. But there's plenty of websites that can show you how to set your Arduino IDE. Please note that you don't have to know everything that works here. And if you're brand new to coding, you can just copy and paste this from the GitHub link in the description. How we make our code is we start by declaring all our ports. This is a really good practice because it lets you know what specific pin does what, and you should always start with this. And then once we get to some of our limitations, such as our ADC max and our ADC min, we declare those there. And then we also have our turn on range. So range is going to be like how many integer values of, like, let's say 100. Every 100 that passes by from 0, we turn on another LED. So this is calculated in our problem to be evenly distributed among all of our LEDs. And then we have turn on LED count. This stores how many LEDs that's going to turn on based off of the range that we're measuring from our ADC pin. And then we have our LED, and then we also have potential value that stores our ADC value. So this is basically our digital value of our analog input. And then we also have LED count. So we need this here because the program needs to know how many LEDs we're working with. And our setup is pretty basic. You're basically just declaring our potential pin, and then you're just declaring all the pins for the LEDs. And then you can create a serial port. Serial ports are really useful as you can see your data live as your program is running. And then once we get to your main loop, we have we get our potential values using analog read. And then once we're done with that, we calculate our max. And then the turn on range is like how many LEDs we're gonna, from the max divided by how many LEDs there are. Pretty, not too complicated here. And then we also have the reason why we calculate our EC pin max in the mid of it, because certain electronics can add a load to your large loads to your electronics, and that can lower the voltage, which will throw off the circuit. So we calculate this in our loop as we go, and then get the number of divisions. This just determines how many times can our rated potential value be divided by how many LEDs are, and that determines how many LEDs we turn on. And then turn on the correct number of LEDs is actually when we start turning them on. And at the bottom we just output some more data, and then that's all the code. And thank you for watching my video today. I appreciate you watching to the end, and have a good day.